called integration by parts, right? So in many cases, we're not going to be able to identify our functions or the integrand in the structure of these immediate integrals that we saw in the last video, right? And so for those cases, you will need more techniques, right? And so then in this video and the next ones, we're going to see how to deal with this. One of the first techniques that we want to learn and we be able to use is what we call integration by parts. Okay, and that means dividing our function, whatever is our integrum. This is normally you will see it like this, right? The primitive of some function h. So we have to be able to separate it into two parts, right? One function f and one function g, which we identify as the derivative of another function. So g prime is another function g, right? If we can do that, then it's guaranteed that this primitive is going to be equal to this, right? And the proof is easy, right? So the proof for this, it just follows from the derivative, the rule of the derivative, right? So we have that the derivative of f times g, right? Well, sorry, let's say a primitive for this, right? A primitive for this is going to be f times g, right? The primitive of the derivative of this. But the derivative of this we can compute using this, the product rule. So this is the product of f times g prime, and then plus the primitive of f prime times g, right? And we can separate these two primitives because we know that this operation is linear, right? Now you just need to solve for this, so take that subtracting to the other side and you get the original formula. Okay, now I guess most of you guys, if you have seen this before, typically you will have seen this like this. The primitive of u times dv, where dv is this, okay, this is what we call dv, is u times v minus the integral of v du, right? And there's some, a lot of mnemotechnic rules to remember this, right? So is this the same as identifying our function u and our function dv, which is g prime dx, and then be able to compute the derivative of f and the primitive of g, right? And so then you have to compute this like this, okay? So a very classical example of this, the application of this formula is to compute the primitive of this, right? So typically, whenever we have an exponential, we want to use this as our g prime or dv if you want, right? And u is going to be x, right? So du is going to be the x, and v is going to be, so this is dx, okay? Using the notation that most of you will have seen, right? In other words, what you can say is that g prime is going to be e to the x, f is going to be x, and then applying the formula, then you have x times e to the x minus the derivative of x, which is 1 times e to the x dx, and the primitive of this is e to the x, so you have e to the x minus e to the x, or in other words, x minus 1 times e to the x, right? That's the primitive, plus c, okay, plus a constant. Okay, so either way works. If you already know how to do it using this notation, then go ahead, just as long as you know what you're doing. If not, you can do it using this notation, okay? Both ways are fine. Okay, so this is useful whenever we have, for instance, a polynomial, right? And that's multiplying, for instance, an exponential or a cosine or sine, things like that, right? So which is easy to integrate several times to find a primitive, and the polynomial is easy to differentiate, and if you do it over and over again, it will disappear, right? So the functions that you have to find the primitive of in this part get simpler and simpler, right? And so you just need to apply this formula over and over again, right? As many times as you need. Okay, so well, using this knowledge, I gave you this exercise to do on your own. X squared plus 1 times the sine of 2x minus 1. Okay, and then let's see, we can, let me go back here. We can actually use this trick to compute, for instance, the primitive of the logarithm, right? So now here, what's the problem? Well, we can see how can we find this as an integration by parts, right? Now, it's clearly f is clearly going to be the logarithm of x, because we don't know the primitive of this, but we know how to differentiate it. But then g prime is, and this is the trick, this is equal to 1. Okay, so then the integral of this is going to be the logarithm of x minus, and then you have the primitive of 1, which is x, one of the primitives, times the derivative of the logarithm, which is x. So this is the primitive of 1, so this is just the logarithm of x. So this is x, sorry, because this is times g, not times f, right? X times the logarithm of x minus x plus c, or in other words, x times the logarithm of x minus 1 plus c. This is the primitive of the logarithm. Okay, so again, if you don't remember this, at least remember how to get it easily using integration by parts.